The last way we're going to learn to graph a line is by using intercept. Remember, an intercept is where the graph crosses an axis. So if we have a y-intercept, it's where the graph crosses the y-axis, and you'll have an ordered pair, 0, y, because any point on the y-axis has an x value of 0. So if we think about sketching a quick little graph here and plotting a few points on the y-axis, we could have the point 0, 1, we could have the point 0, 10, we could have the point 0, negative 5. Those would all land on the y-axis. So when we solve for a y-intercept, we substitute 0 for x and solve for our y value. Kind of the opposite is if we have an x-intercept, we are on the x-axis, we would have an ordered pair x, 0, because anywhere on the x-axis, your y value is 0. You could have 2, 0, you could have 6, 0, you could have 12, 0, you could have negative 3, 0, you could have negative 9, 0. You have an x value, but you're not going up or down, so your y value is 0. So to solve for an x-intercept, you substitute 0 for y and solve for x. So our essential question today is, what is an intercept? Hopefully we've already solved that problem. And how do we use them to graph? We talked about that as well. So looking for our y-intercept first, remember f of x replaces y. So to find a y-intercept, you substitute 0 for x and you solve for the y value, or in this case we're solving for our f of x value. After we replace x with 0, we multiply 0 by 2 to get 0, and 0 minus 8 is negative 8. So we have the ordered pair 0, negative 8 for our y-intercept. Our y value, or our f of x value, when x is 0, ended up being negative 8. Now we're going to do something similar to solve for our x-intercept. This time we're going to replace the y with 0. F of x is simply notation for y, so the whole thing turns into a 0. There's no f and there's no x on the left-hand side. Solving for x, we're going to add 8 to both sides. On the right-hand side are minus 8 and plus 8 canceled. Next, we're going to divide both sides by 2 to cancel the 2 on the right-hand side, and we get an x value of 4. So this one, when you write your ordered pair, make sure the x always goes first, and we got an output of 0. Plotting those two values, our y-intercept was 0, negative 8, and our x-intercept was 4, 0. Once you've got your 2 points, you simply connect them with a line. We'll see how to solve for x and y-intercepts when we have a fraction. Solving for the y-intercept is always easy because we're substituting 0 for x. So when we replace our x value with a 0 and we multiply 0 by a fraction, it doesn't matter what we multiply 0 by, we still get 0. So we have 0 plus 2 equals 2. Our ordered pair, when we had an input of 0, we got an output of 2. Solving for the x-intercept will be a little bit trickier. Substituting 0 for y and solving for our x. Subtracting 2 from both sides. Now for some of you that aren't real comfortable with fractions, you might want to solve this next piece in 2 steps. For some of you who are a little bit more comfortable with fractions and a little bit more comfortable with solving, you might be able to do this all at once. So I'm going to show this in 2 steps first, and then I'll quickly explain how to solve it in 1 step for those of you that might be comfortable trying it that way. This bar right here, remember, means division. So I'm going to cancel my division by multiplying both sides by 3. So I have negative 6 equals negative 2x. Then I can divide both sides by negative 2 and get 3 equals x. So my ordered pair, my x is my input. I got 3 when y was 0. In my right-hand column, I'm going to show you how to do that in 1 step. So we had -2 equals -2/3 x. To cancel both the multiplying and the dividing at the same time, you multiply by the reciprocal. So you can multiply both sides by 3 over -2. On the right-hand side, again, the 3 in the numerator cancels with the 3 in the denominator, and the -2 in the numerator cancels with the -2 in the denominator, leaving you with x. On the left-hand side, you can think about your -2 being over 1, and the -2's cancel, leaving you with 3. So depending on your comfort level, you can choose which way you want to go about solving for your x-intercept in this case. Plotting both those points, we had 0, 2 for our y-intercept and 3, 0 for our x-intercept, and then we can connect them with our line. And of course, we need to see a special equation. We've got y equals 2. So we can think about solving for our y-intercept. If we replace x with 0, well, there's no x to replace, so we get y equals 2. So our y-intercept is 0, 2. For our x-intercept, let's see what happens when we replace y with 0. We get 0 equals 2, which is not true. What that means is there is no x-intercept. So here's another way we can think about graphing these special lines. This line has a y-intercept at 0, 2, but it never crosses the x-axis. So you can think about what kind of line goes through that point and never crosses the x-axis. You might remember about parallel lines. Parallel lines are lines that never cross because they go in the same direction. So you can think about having a line that goes in the same direction as the x-axis through the point 0, 2. So that's how we end up with a horizontal line. And you have one you try on this one. See if you can solve for your x and y intercepts and get a graph.